Om Sri Guru Basavalinkaya Namaha. In our last class, we completed what is that one? Our NCERT problems other than the additional problems. Okay. Now we will move into the problems which are related to competitive exams regarding electric potential and capacitance. Electric potential and capacitance. Okay. Try to see the first problem. If electric potential, first one, if electric potential V at any point xyz, V at any point x comma y comma z, x comma y comma z in space given by V is equal to 4x square, V is equal to 4x square. The electric field at a point 1, 0, 2 meter is dash. See here, the electric potential V at any point is given by V is equal to what? 4x square. The electric field at a point 1, 0, 2 meter is dash. Try to tell what is the relation between them. Electric field is negative potential gradient. Electric field is what is that one? Negative potential gradient. But here points given means we may write what is that one? E bar is equal Ex I cap plus Ey j cap plus Ez k cap. Okay. Here potential given as a function of what? X. That means its corresponding electric field is also having only Ex. So therefore Ex is equal to what to write? Minus dV by dx. Ex is equal to what? dV by dx. So minus d by dx of V how much given? 4x square. That is equal to what? Minus x square differentiation 2x. So 4 into 2x, that is equal to what? Minus 8x. Here at point 1, 0, 2 meter. Here at point 1, 0, 2 means what? This is x, this is y, this is z. So substitute x is equal to what? 1. X is equal to what? 1. So Ex is equal to how much? Ex is equal minus 8 into 1, that is minus 8. Therefore E bar is equal to what is that one? Minus 8 I cap. E bar is equal to minus 8 I cap. Okay. Ex is what is that one? 8. So E bar is equal to what? Minus 8 I cap. In other words, we may write electric field is 8 volt per meter along negative x axis. Along negative x axis. Okay. Suppose here the function given V is equal 4x square plus 5xy. Then what you should do? You should take Ex and Ey both. Okay. Here how many variables are there in V? We should take that much of components. We should take that much of components. Next one. Another one. Find the potential difference. Find potential difference between points A and B at A is 2 comma 1 comma 1 meter, and B is 0 comma 2 comma 4 meter. B is 0 comma 2 comma 4 meter. In an electric field, E bar is equal to, what is that one? Xi cap minus 2y j cap minus 2y j cap plus z k cap volt per meter. Here we want to find out potential difference between points A and B at 2 comma 1 comma 1 meter and B 0 comma 2 comma 4 meter in an electric field. E bar is equal to xi cap minus 2y j cap plus z k cap, okay, minus 1. Okay. See, here electric field we want to find out. So, already we know E is equal to what? Minus dV by dr. From this, V is equal, you may write minus integral E dr. Yes or not? Here V is equal, E is equal to what? Minus dV by dr. We want to find out potential difference. So, V is equal, if you take integration on both sides with respect to r, that integration differentiation cancel. So, here only integration remains. So, we may write integral E dr. Here limits what you should take? A to B. Limits A to B. So, this one we may write V is equal to minus. Here what is the limits? 2 comma 1 comma 1 to 0 comma 2 comma 4. 0 comma 2 comma 4. Here what is this one? E bar xi cap minus 2y j cap plus z k cap dot dr bar. Dr bar means what to write? dxi cap plus dy j cap plus dz k cap. R bar is equal to, you know, what is R bar? R bar what? xi cap plus yj cap plus zk cap. So, here E dr, this is nothing but E bar dot dr bar. Yes or not? So, E bar means what is given, that one I wrote, and dot dr bar means dxi cap, dyj cap, dzk cap. So, V is equal to minus integral 2 comma 1 comma 1 to 0 comma 2 comma 4 dot product. I cap dot I cap 1, j cap dot j cap 1, k cap dot k cap 1, remaining zeros. That is why what to write? X dx plus x dx, next what? Plus minus 2y dy, next plus z dz. You may write like this. So, by simplifying this one, you may write, what is that one? V is equal to minus, here x integration what? X square by 2. Next minus 2 y integration y square by 2. Next plus z integration z square by 2. Yes or not? Limits what? 2 comma 1 comma 1 to, what is that one? 0 comma 2 comma 4. So, this one you may write V is equal to minus, suppose 1 by 2 is common, then you may write x square minus 2y square plus z square. Here 2 comma 1 comma 1 to 0 comma 2 comma 4. So, V is equal to minus 1 by 2. First upper limits. What is this one? 0 square minus 2 into 2 square plus 4 square. Minus lower limits. 2 square minus 2 into 1 whole square plus 1 square. Upper limit, lower limit values. So, V is equal to minus 1 by 2. What is the remaining here? 2 square 4, 4 to the 8. So, minus 8 plus 16. This one minus 4 plus 2 minus 1. So that is minus 1 by 2 into 16 plus 2, 18, minus 8 plus 4, 12, 12 plus 1, 13. Okay. So minus 5 by 2, that is what? 2.5. What is that one? 2.5. That is the potential difference. Okay. Potential difference between points. This concept, okay now? Here always E and V, how you relate? E is equal minus dV by dr. That means if the potential is expressed, okay, if the potential is expressed, then the electric field, how you write? Minus dV by dr. If the potential is in function of x, minus dV by dx, Ex. If that is in function of y, minus dV by dy. If that is in function of z, minus dV by dz. Okay. Function of x and y like this means those two terms we should take. For Ex, we should keep I cap. For Ey, we should keep j cap. For Ez, we should keep k cap. Suppose E given potential one means what? V is equal to minus integral E bar dot dr. Here E bar is what? Ex I cap plus Ey j cap plus Ez k cap. What is given? That one. And dr bar means what? Dx I cap plus dy j cap plus dz k cap. In dot product here only what is that one? What is the remaining? This I cap coefficient into that I cap coefficient plus j cap coefficient into j cap coefficient plus k cap coefficient into k cap coefficient. Points given means what? The first point we should consider as lower limit and second point is considered as upper limit. Okay. Potential difference between A and B means what? A should be considered lower, B should be considered higher. This is very, very important model. What is that one? Regarding the relation in between electric field and electric potential. Electric field and electric potential. Next, another one. The electric potential at a point A is the electric potential at a point A at a point capital A is 20 volts, is 20 volts. Next, and at B minus 40 volts and at B minus 40 volts. Find the work done. Find work done by external force. By external force. Find the work done by external force. External force. In moving electron. In moving electron slowly from B to A, moving electron slowly from B to A. How much? Very good. So here we want to find out work done. What is the work done? W is equal Q into V. In between any two points given means what? The required work done dW is equal Q into D, potential difference. So here B to A asked. So we should write potential difference in between B to A. Here what is that one? Q means electron, 1.6 into 10 to the power of minus 19 Coulomb. So dV means what? Here potential difference. This one B to V. So final point what? B to A. Final point A. So VA minus V. Okay. So you may write 1.6 into 10 to the power of minus 19. VA means what? 20 minus of minus 1. So that is 20 minus of minus 40 means what? 60. So into 60, that is equal 96 into 10 to the power of minus 19 joule. This is what is that one? Work done, external work done. Suppose electron work done asked, then it will become what? Negative. Electron work done mentioned, then that is what? Opposite to external work. So external work is, what is that one? This 96 into 10 to the power of minus 19 joule. So electron work done asked, then automatically it will become what? Minus 96 into 10 to the power of minus 19 joule. Only sign convention will be opposite. Next one, another one. 3 concentric spherical metal shells. 3 concentric spherical metal shells. Spherical metal shells A comma B and C. A comma B and C of radii A comma B comma C such that C is greater than B greater than A. C is greater than B greater than A. Have surface charge densities. Have surface charge densities. Surface charge densities. What are those? Plus sigma, comma minus sigma, and plus sigma respectively. Plus sigma respectively. Next one, find the potentials of 3 shells. Find potentials of 3 shells. Here, what is that one? Find the potentials of 3 shells. Potentials we should find out. Okay. What is the potentials across the 3 shells? Here we should find out the potentials across 3 shells. Okay. This is what is that one? One shell. This is another shell, and this is another shell. Here this radius is A, and this radius is B, and this radius is C. Okay. Here at A, its surface charge density plus sigma. Here minus sigma. Okay, and at here plus sigma. This is the surface charge density. Okay. Here, how you find out? It's corresponding what they are asking, potentials on 3 shells. Potentials on 3 shells. Now, try to tell what is the charge on A. Charge on A what? Here spherical shell means what is surface area? 4 pi r square, and charge density sigma. So we may write sigma 4 pi r square means A square. Similarly, charge on B, how much? Sigma 4 pi B square, and charge minus, and charge C is sigma 4 pi C square. This is clear. Now potential. Here potential on A. Here what they are asking, individual potentials only, na? Potential on A. Here always what you should remember? You should remember charge resides on outer surface. Charge resides on outer surface. If charges are nearer, then at each and every point all potentials are active. All potentials are active. So if you consider a certain point on A, then at this how many charges are acting for potentials? 3. QA is acting, QB is acting, QC is acting. So here what is VA tell? 1 by 4 pi epsilon naught into QA by A plus QB by B plus QC by C. Yes or not? So here VA is equal, how you write? 1 by 4 pi epsilon naught into QA by A, means what? Sigma into 4 pi A. This one minus sigma into 4 pi B. This one plus sigma into 4 pi C. You may write like this, sigma by what is one? QA by A. QA by A means what is the remaining? Sigma 4 pi A. Similarly, QB by B, sigma into 4 pi B minus, and QC by C plus sigma into 4 pi C by C. So VA is equal to, what is cancel? 4 pi cancel. So sigma by epsilon naught into A minus B plus. This is VA. Similarly, suppose VB we are considering. What we are considering? VB. Potential at 3 points asked now. How many points asked? 3 points. So potential at B, how much tell? 1 by 4 pi epsilon naught into, now here if you are considered, means already we know, this is very, very important here. What is that one? Here we are finding, means this charge you should take in it here. QA charge, now you should consider it where? On QB. That means what? QA plus QB divided by B. This is okay now. Here this inner sphere is there now. This charge is also considered on outer sphere. That means on outer sphere total charge what? QA plus QB divided by B plus total outer QC by C. This is important point here. Okay. So now VB is equal, how you write? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Here QA by B. QA what? Sigma 4 pi A square. So sigma into 4 pi. Here A square plus B square divided by B. Divided by B. Okay. Next. Plus QC what? Sigma into 4 pi C square divided by, what is that one? C. So this one cancel. This one we may write VB is equal 4 pi cancel. So sigma by epsilon naught into A square plus B square, not B plus A, minus na. This is what? Minus. Why? For the second QB it is negative. So minus. So here A square minus B square divided by B plus C. This will become, what is that one? Potential at B. Similarly, you should try to tell potential at C. Potential at C. At C, if you consider any one point, here only you should consider QA, here only you should consider QB, here only you should consider QC. Why? Because charge resides on outer surface. Charge resides on outer surface. If you calculate here, no problem. Only charge at any charge that will be there. If you consider second sphere, the first sphere charge also comes to second sphere. If you consider the third sphere, first two sphere charges also comes to third sphere. So at third sphere we see how we write 1 by 4 pi epsilon naught. Only third sphere we should consider. So by C, here what? QA plus QB plus QC. Okay. At inner sphere what? At inner sphere QA by A plus QB by B plus QC by C. Middle, second sphere QA plus QB by B, here QC by C. Third sphere, all charges comes to outer sphere. So QA plus QB plus QC divided by C. So this one we may write VC is equal, what is this one? Sigma 4 pi outside. So sigma by epsilon naught. This one what? A square minus B square plus C square divided by C. This will be VC. This is very, very important concept here. Okay. Here whenever the potential is calculating, what you should remember, if you consider the lower sphere, then each and every charge should be there only. If you consider the second sphere, inner and that sphere charge comes to second sphere, outer is outer there only. If you consider the outermost sphere, all charges you feel that they are on outer surface. That is why here at outer surface QA plus QB plus QC by C. At the middle QA plus QB by B plus QC by C. At the innermost QA by A plus QB by B plus QC by C. This is okay now? So what you should remember, whenever you are calculating in the concentrating bodies, what you should remember, inner side means what? You should consider every charge is residing on its sphere. But if you are moving away from the inner side, inner sphere, then charge will be accumulated up to that point. Charge will be accumulated at that point. That means what? Suppose here 3 concentric spheres are there. Here the charge is plus 5 coulomb, here minus 2 coulomb, and here plus 8 coulomb. If you are calculating here, then what you should do? 5 divided by its radius, minus 2 divided by its radius, plus 8 divided by its radius. If you are calculating here, then what you should feel? 5 minus 2, 3 divided by this radius, plus 8 divided by this radius. If you are calculating here, then total 11 divided by only this radius, divided by that radius. Understood? So what you should remember here, in the case of concentric bodies, you should remember charge always resides on outer surface. That means at anywhere you are calculating the potential means what? The below that range, all the charges are comes to there. All the charges are comes to there. Here you are calculating here means what? Below this no charge. So that's why this charge divided by its radius. Here means below some charge is there. So this charge plus this charge, QA plus QB divided by B. Here means QA plus QB plus QC divided by C. Understood? That one we should remember when you are calculating the potential at a given point regarding concentric spheres. Regarding what is that one? Concentric spheres. Now I will give orally, try to tell. Suppose this is one sphere and this is second sphere, this is third. This is plus 5 coulomb, minus 5 coulomb, plus 5 coulomb. This is point A, this is point B, this is point C. This radius is R, this radius is 2R, this radius is 3R. Now, what is the potential at point B? This is 5. What is potential at point B? 0. Why? Plus 5 minus 5. Total charge here what? 0. Here on which sphere potential is more? A, B, C. On which sphere potential is more? A. Why? Because here QA divided by R. Same here the term will become QA divided by 3R. So denominator is increasing. So its value decrease. Understood? So this point is very, very important. So what you should remember, in the case of concentric spheres, at any point you are calculating the potential, means what you should remember, charge will be accumulated at that point. Which charge? Inside charge. Outside charge as it is, but inside charge should be accumulated, means we should add. Okay. Next one. Now another one. Charge Q1 is fixed. Charge Q1 is fixed. And another charge Q2, another charge Q2 is placed at a distance r naught from q1 on frictionless surface, on frictionless horizontal surface. Okay. Next, find velocity of charge q2, velocity of charge q2, as a function of separation small r, as a function of separation small r, between them. Consider mass of q2 is m. Okay. Here what is that one? Charge q1 is fixed and other charge q2 is placed at a distance r naught from q1 on a frictionless horizontal surface. Find the velocity of q2 as a function of separation small r, between them. Okay. We want to find out its corresponding, what is that one? Velocity expression we want to find out. How you find out? Here this is the charge q1 and here this is the charge q2 and this q1 is at rest and this q2 is about r naught distance from q1. Okay. Now we want to find out if the charge q2 is moving with certain velocity, then we want to find out this velocity expression as a function of separation r, How you find out? According to law of conservation of energy. What is meant by law of conservation of energy? Energy can be neither created nor destroyed. Suppose here the potential energy is U1, kinetic energy is K1, and here potential energy is U2, kinetic energy is K. Then according to law of conservation of energy, U1 plus K1 is equal to what? U2 plus K. Yes or not? Here what is the potential energy due to Q1 charge? What is the separation? R naught, and this charge is present or not? Present. So what is the potential energy? 1 by 4 pi epsilon naught Q1 Q2 by R naught. Q1 Q2 by R naught plus kinetic energy of first one 0. Why? That is at rest. And second one potential energy what? 1 by 4 pi epsilon naught Q1 Q2 divided by, we want to find out, this is a separation, a function of new separation R. So when it comes into motion, it will become what? R. The distance between Q1 and Q2 now not R naught. Why? Already it comes into motion with velocity V. So R plus its corresponding kinetic energy what? Half mv. So simply V square is equal to what? 1 by 4 pi epsilon naught, here Q1 Q2 by 4 pi epsilon naught, 1 by R naught minus 1 by R. And what is this one? This is half mv square. So what is this one? Here 2 2 ja. So V square is equal to what? Q1 Q2 divided by 2 m pi epsilon naught into 1 by r naught minus 1 by r. So V is equal root over what is that one? Q1 Q2 by 2m pi epsilon naught into 1 by r naught minus 1 by r. This is positive value or negative value? Positive. Why? This r is greater than the r naught. So automatically that will become what? Positive. Okay, now this one here like this, any velocity asked means what? Immediately you should apply only one way. What? Applying law of conservation of energy. So if this is at rest, means kinetic energy 0, K1 0, and potential energy means initially how much is there from Q2 distance, that distance we should consider. So 1 by 4 pi epsilon Q1 Q2 by R naught. Okay now, and we want to find out when it moves with certain velocity. Here we want to find out velocity in terms of R, new separation. So now potential energy U2 not U1, that is changing. So 1 by 4 pi epsilon Q1 Q2 by R plus its kinetic energy half mv. Continuously changing. No. This velocity at separation R only we are considering. If R changes, then automatically V changes. For the particular what is that one expression should not apply sigma. Why? Sigma means those are adding. These are not like that. These are instantaneous. For a particular R, V is having particular value. R changes, V changes. Summation means what? Earlier we should add. That is not correct. So here R value changes, so V value changes. That means for a particular R, V is having only one value. V is having only one value. So you should not apply summation. Summation means what? Continuously values are adding. Here not added. At each and every one, that those are V1, V2, V3, those are also V infinite. But we should not add. Okay, next one. Any doubts are there in counseling, you should talk. Next one. A particle of mass 40 microgram, a particle of mass 40 microgram, and carrying charge 5 into 10 to the power of 9 coulomb. 5 into 10 to the power of 5 into 10 to the power of minus 9. 9 means very huge. So 5 into 10 to the power of minus 9 coulomb is moving directly. Towards fixed positive charge. What is that one? Of magnitude 10 to the power of minus 8 coulomb. 10 to the power of minus 8 coulomb. When it is at a distance of 10 centimeter, when it is at a distance of 10 centimeter, when it is at a distance of 10 centimeter, its velocity 50 centimeter per second. Its velocity 50 centimeter per second. Now, at what distance? At what distance from the charge? At what distance from charge? At what distance from charge particle comes to rest? Particle comes to rest. At what distance particle comes to rest? Okay. Try to find out at what distance the particle comes to rest. Here, what is this one? A particle is there and its mass is what? This is considered particle. This particle mass 40 microgram, means 4 into 10 to the power of minus 5 gram. That means 4 into 10 to the power of minus 8 kg. Next is carrying a charge. Its charge is given, consider Q1, that is 5 into 10 to the power of minus 9 coulomb. That is moving directly towards a positive charge of magnitude. If a positive charge is considered, its charge Q2 is equal 5 into 10 to the power of minus 9 coulomb. It is moving like this. That is moving like this. So, when it is at a distance of 10 centimeter, its velocity 50 centimeter per second. So, if you consider like this, now suppose this is considered point P1, then this distance R1 is equal 10 centimeter, means 10 to the power of minus 1 meter. Here its velocity V1 is equal 50 centimeter per second, means what? 5 into 10 to the power of minus 1 meter per second. At what distance from charged particle comes to rest? Suppose at point P2, if it comes to rest, means V2 is equal 0, then this distance R2 is equal to how much? We are asking. They are asking at what distance it comes to rest. How you find out? Again, by applying law of conservation of energy. So, here by according to law of conservation of energy, according to law of conservation of energy, at point P1, U1 plus K1 is equal, at point P2, what is that one? U2. At point P2, what is that one? U2. Why? Because that comes to rest. That comes to rest means what? Here its velocity V2 is equal to. Now, U1, what is the formula? 1 by 4 pi epsilon naught Q1 Q2 divided by initial what? Distance R1 plus half m, what is that one? V square. Okay, that is equal to V1 square. U2 what? 1 by 4 pi epsilon naught Q1 Q2 divided by here R2 we want to find out. So, able to find out or not? So, what is 1 by 4 pi epsilon naught? 9 into 10 power 9 into Q1 Q2. Q1 how much? 5 into 10 power minus 9. Q, what right? Both are same. This is 10 to the power of minus 8. Q2, how much this one? 10 to the power of minus 8. So, what? 5 into 10 to the power of minus 9 into 10 to the power of minus 8 divided by R1 what? 10 power minus 1 plus half into mass what? 4 into 10 to the power of minus 5 into velocity square how much? 25 into 10 to the power of minus 2. That is equal, here what? 9 into 10 to the power of 9 into 5 into 10 to the power of minus 8 minus 9 into 10 to the power of minus 8 divided by R. Able to find out R2 or not? Particle. What is given mass of the particle? 40 microgram. 40 microgram means 4 into 10 to the power of minus 8. Where I convert? 4 into 10 power minus 8. Very good. So, 10 to the power of minus 8. Try to find out. Here what? 2500, 10 power minus 2 cancel. 10 power 9, 10 power minus 9 cancel. So, 9 5 how much? 45 into 10 to the power of minus 7 plus this one what? 0.5. So, 0.5 into 10 to the power of minus 8 is equal, there what? These two cancel, 9 5 45 into 10 to the power of minus 8, okay, divided by R. So, this one you may write 450 10 to the power of minus 8. So 10 power minus 8, 10 power minus 8, 10 power minus 8 cancel. So 450.5, 450.5 is equal 45 by R2. So R2 is equal to what, right? 450.5 by 45. So 45 10 ja 450. So 10.01 meter. Is that? So at about how much distance? 10.01 distance. What happened here? The particle comes to rest. Okay. So like this. So what you should remember, wherever the positions and velocities are given, wherever the positions and velocities are given, then you should apply only one thing. What? Law of conservation of energy. So sum of the potential kinetic energies at first point should be equal to sum of the potential and kinetic energies at the second point. Sometimes they may ask force also. Suppose force asked means how you find out? Force is the negative potential gradient, potential energy gradient. So F is equal to what? Minus du by dr. F is equal to what? Minus du by dr. Okay. Next, another one. A proton moves with speed, a proton moves with speed 7.45 into 10 power 5 into 10 power 5 meter per second directly towards a free proton, directly towards a free proton, originally at rest. Okay. Next, find the distance of closest approach. Find distance of closest approach. Find the distance of closest approach of two protons. We want to find out closest approach of two protons. Able to find out or not? Closest approach means what? Distance. Distance to find means what you should consider? Law of conservation of energy. So here let us consider this is the first proton, okay, P1, and this is the second proton. This is at rest. Okay. Here the first proton is moving with certain speed, that is 7.45 into 10 to the power of 5 meter per second, and mass of the proton, you know what? Mass of the proton how much? Mass of the proton 1.67 into 10 to the power of minus 27 kg. So 1.67 into 10 to the power of minus 27 kg. And here if it is moving like this, then what happened? In between two protons, attractive force is acting or repulsive force is acting? Repulsive force. Attractive force is acting or repulsive force is acting? In between two protons, both forces are acting. Attractive force and repulsive force. When attractive is acting, when repulsive acting? If the distance is greater than 1 Fermi. If the distance is greater than 1 Fermi, then what is that one? Attractive force is acting. If that is moving towards the proton, one proton is moving towards the other proton about 1 Fermi, then the repulsive force is acting. Similarly, in between proton and electron, attractive force is acting, repulsive force is acting. Both are acting. It's reverse. That means what? Due to opposite charges, electron attracting towards the proton. But when this is moving about 1 Fermi distance, then automatically in opposite direction, that means due to nuclear forces, the repulsive force is acting. That is why don't think that proton both are positive charge, that is why force of repulsion is acting like that. Okay? Here force of attraction and force of repulsion both are acting. Only up to closest approach, what is the one? Attractive force is acting. After that, repulsive force is acting. So, the closest approach we should see. That means after moving this one, it comes back. That means repelled. Initially, this is attracted. After that, that is repelled. So, here velocity is there, this one is there, and distance is there. So, here which force is acting? Potential energy is acting. And here that is at rest. So, here only what is that one? U2 is acting. Okay? U2 means what? That is what is that one? Only potential energy is there. Here potential energy and kinetic energy is there. So, according to law of conservation of energy, we are able to apply U1 plus K1 is equal to what? U1 plus K1 is equal to what? U2. Here, what is this one? Suppose if this is considered as what is it one? Closest approach R0. That is considered as closest approach R0. This closest approach R0, this one should be 1 Fermi. 1 Fermi means R0 is equal to what? 10 to the power of minus 15 meter. Okay. So, this will be the minimum distance, least distance which is moving close to second proton. So, this one considered R. We want to find out this R value. We want to find out which R value? This R value. So, in U1 you should consider the distance what? R, and at U2 you should consider distance what? R0. Okay. So, here we may write what is that one? U1 means 1 by 4 pi epsilon naught, Q1 Q2 means E square divided by what is the first distance, this one? R plus half m V square, that is equal U2 what? 1 by 4 pi epsilon naught E square by what is this distance? R0. R0 means what? 1 Fermi. So, R0. Now, able to find out R value or not? Closest approach. So, this one what? 9 into 10 to the power of 9. E square means 1.6 into 1.6 into 10 to the power of minus 38 divided by R plus half into 1.67 into 10 to the power of minus 27 into V square. How much? 7.45 into 7.45 into 10 to the power of 10, that is equal here what? 9 into 10 to the power of 9 into E square what? 1.6 into 1.6 into 10 to the power of minus 38 by 10 to the power of minus 30 R square. So, R naught square, R naught only nara, minus 15, not minus 30, R naught. So, minus 15. Now, by simplifying this one, try to calculate that one. Okay. Here minus 9 means this will become what? 27. Okay. And here 9, 15, 10 to the power of 9, how much? 29, 29. So, this is 29, here 27 is there. So, if you write this one as minus 29, it will become 10, 12. Okay. Next, this one also, what is it? Minus 29. So, 10 power minus 29, 10 power minus 29, and this 10 power minus 29 cancel. Okay. Remaining, try to simplify. 9 into 1.6 into 1.6 by r plus this one what? 7 7 is 49, approximately 50. Okay. So 50 by 2, 25. 25 into 1.7, 1.7. So 25, 7 is how much? 135. So approximately 40 into 10 to the power of how much? 12. That is equal this one, 9 into 1.66 into 1.6 into 10 to the power of 15. Okay. So here 9 into 1.6 into 1.6 by r is equal, here what? 10 to the power of 15. So this one 10 to the power of 15 means this will become how much? 0.4. 0.4. So here what? Approximately that is 9 into 1.6 into 1.6 into 10 to the power of 15. Why 0.4 means negligible? So here these three cancel. So r is equal 1 by 10 to the power of 15 means approximately 1 Fermi. R is also approximately 1 Fermi, but greater or lesser means what? This is less than this by 0.4 coefficient, so comes into denominator. So we may write little bit greater than 1 Fermi, little bit greater than 1 Fermi. That is the closest approach. That is the closest approach. Okay, little bit greater than 1 Fermi. Understood? So here closest approach or velocity problems are given means what? Immediately you should apply what? Law of conservation of energy. That means the total energy at point 1 should be equal to the total energy at point 2. Understood? Next one, another one. So try to do, we will do some little bit capacitor problems. Okay. Two conductors carrying equal and opposite charges, equal and opposite charges produce a non-uniform electric field, electric field along x-axis as E is equal Q by epsilon naught A into 1 plus Bx square Find its capacitance. See, two conductors carrying equal and opposite charges produce a non-uniform electric field along axis as E is equal to Q by epsilon naught A 1 plus Bx square. We want to find out capacitance. Capacitance C is equal to what? Q by V. So by using this we want to find out V. If electric field is given, V is equal to what? Tell? Integral E dx. So here integral E what? Q by epsilon naught A into 1 plus Bx square dx. So this one you may write V is equal to what? Q by epsilon naught A constant. integral 1 dx means what? X plus integral bx square. How much? Bx cube by 2. So from this, q by v is equal to what? Epsilon naught a divided by x plus bx cube by 3. Q by v is nothing but what? C. So capacitance is given by epsilon naught a by, here if x is take common, 1 plus bx square by 3. Yes or not? So what is that one? The capacitance is given by C is equal epsilon naught a by x into 1 plus bx square by 3. Here what you should remember, electric field given and capacitance find means what? C related to Q and V only, not related to E. So first you should find out V. V is equal to what? Integral EdR or integral EdX. So if you know its corresponding potential, then automatically the capacitance you may find out C is equal to what? Epsilon, that means Q by V. So you are able to find out its corresponding capacitance value. Next one. Next one. A metal slab. A metal slab. A metal slab of thickness. A metal slab of thickness equal to half of the distance. Equal to half of distance. Half of distance. Half of distance between the plates. Between plates introduced is introduced. Is introduced. Okay. Then its capacitance becomes how much? Its capacitance becomes dash. Here see, first I am considering only capacitance with air as the medium, and A is area and D is the thickness. Then what is the capacitance in A? Epsilon naught A by D. Epsilon naught A by D. Okay. Now this is the capacitor. Here this area is A and separation is D. Now I am introduced a metal plate, means K is equal to what? Infinite, and its thickness T is equal to what? D by 2. Its thickness T is equal to what? D by 2. Now its new capacitance C is equal to what is our formula? Epsilon naught A by D minus T plus T by K. Yes or not? If any dielectric of dielectric constant K is introduced, then new capacitance, what is the formula? Epsilon naught A by D minus T plus T by K. Here K is infinite, so T by infinite what? 0, and T is D by 2. So you may write epsilon naught A by D minus D by 2 plus 0. So it will become C is equal to what? Epsilon naught A by D by 2. That is 2 epsilon naught A by D. So it will become what? 2C naught. So the capacitance will become what? Twice. Capacitance will become what? Twice. So here any dielectric or metal plate, whatever it may be, of certain thickness T is introduced in the capacitor, its new capacitance C is equal to what? Epsilon naught A by D minus T plus T by K. Suppose two dielectrics are introduced with thicknesses T1 and T2 with dielectric constants K1 and K2. Then what is the capacitance formula? Epsilon naught A by D minus of T1 plus T2 plus T1 by K1 plus T2 by K2. Like that we are able to find out its capacitance. Like that we are able to find out its capacitance. Okay. Next, another one. Another one. Okay. In the network, 3 identical capacitors are connected as shown. Each of them can be withstand with 100-volt potential difference. Each and every one is able to withstand about 100-volt potential difference. Okay. Then, what is the maximum voltage that can be applied across A and B so that no capacitor gets spoiled? Here we want to find out VAB maximum is equal to how much? Hey, we want to find out VAB maximum how much? How much till maximum? VAB maximum, how much we are able to apply? Here already we know VAB is equal, Q is equal to what? CV. Q is equal to what? C. So here we want to find out V means first, if you write this is first capacitor, this is second capacitor and this is third capacitor, then Q1 is equal to what? C into 100. So 100 C. And Q2, how much? C into 100. So what is that one? 100 C. And if that is 3, Q3 is equal to what? 100 C. Here all charges are what? 100, 100, 100. Now we want to find out the maximum potential. So CAB, here these two are in how? Parallel to each other. In parallel combination, what is the effective capacitance? C1 plus C2. So here C plus C, 2C. That 2C is in series with C. So effective what? 2C into C by 2C plus C. Is that right? So it will become 2C by 3. So now you know total charge and you know total potential. So you are able to find out VAB maximum. So VAB maximum is equal, what you write? Q is equal to CV. So V is equal to Q by C. So Q1 plus Q2 plus Q3 divided by CA. Is that right? Divided by CA. Here the, suppose here and here charge is there. Okay. Now how you write this one? Tell. Q1 plus Q2 plus Q3 how much? Q1 plus Q2 plus Q3 how much? 300 C divided by CAB how much? 2C by 3. So CC cancel, 2 150 jar, that is equal 450 volts. VAB maximum how much? 450 volts. So here total 450 volt maximum we are able to apply, and already we know Q, if charge is constant of the entire system, then C inversely proportional to V. C inversely proportional to V. So across these two capacitors, here its capacitance 2C, so we are able to apply 150 volts. And here we are able to apply 300 volts. Like that we are able to find out the potential. Okay. Here total system only asked, so we are able to apply what? 450 volts. Suppose the same question given, and in between A and B already battery is connected. In between A and B what is connected? Battery connected. Battery connected means what remains constant? Potential remains constant. Potential remains constant. Potential remains constant means what? This total 100 plus this is 100. That means totally we are able to apply maximum what? 200. Maximum what? 200. That condition is given means like that. Condition not given means we are able to apply any amount of potential. So it will become, what is that one? 450 volts. It will become how much? 450 volts. Okay. Next one. Another one. Here try to see carefully. Find out the effective capacitance in between A and B. Find out the effective capacitance in between A and B. Here try to tell due to these two, what is the effective capacitance? What is the effective capacitance due to these two? 0. Why? Because this is short circuited. This is what? Short circuited. Short circuited means current, total current flows through this only. Current flow means charge flow. So total charge is flowing like this means here how much charge is there? No charge. No charge. No charge means what is the capacitance? No capacitance. So always when you are solving the problems, this is important. At anywhere short circuit is there means what? Those capacitance you should ignore. Those capacitance you should ignore. So only these two are there. These two, how these two? Parallel. So CAB is equal, parallel combination means what? C1 plus C2. So 8 plus 8. How much? 16 micron. Parallel. Resistance parallel different. So capacitance parallel. So what? C1 plus C2. So 8 plus 8. How much? 16 micron. Understood this one? At anywhere like this direct line is there. Direct line means what? Short circuit. Short circuit means capacitance will become ineffective, inactive. So we may ignore that capacitance. We may ignore that capacitance. Next, another one. Here what is this one? Find effective dielectric constants. Right? See carefully. Find effective dielectric constants. K is equal to what? Okay. Here how many capacitors are there? 3. Okay. This is considered first capacitor, and this is considered second capacitor, and this is considered third capacitor. In this, try to tell any combination, parallel combination, series combination, we should first consider parallel combination. Observe carefully there. One problem done means remaining easy. Parallel combination means what? Common points, means common plates. Here common plates are for joined for which capacitors? First capacitor, second capacitor, third capacitor. In this common plates are having by which capacitors? 1 and 2. Why? 1 this side plate and this side plate are connected. So here what you should remember, 1 and 2 are in parallel. 1 and 2 are in parallel, and that combination in series with 3, this is understood means remaining easy. Here first by seeing that which are parallel, which are series, we should recognize. first try to recognize parallel. Parallel, how you recognize? Common plate there, parallel. Common plate not there means not parallel. Here 1 and 2 both are having common plate. Okay, so parallel. And this combination and this combination having any common plate? No, only this is line, not the plate. So here this combination is in series with third capacitor. So total effective capacitance, how you write? 1 by C effective, or you may write C effective. C effective is equal to, C effective, how you write, tell? 1 and 2 in parallel means what? C1 plus C2. That is in series with 3. So into C3 by C1 plus C2 plus C2. You may write like this. Here C effective is equal 1 and 2 are in parallel. So C1 plus C2. And that combination is in series with C3. So series means what? C1 C2 by C1 plus C2 only now. So C1 plus C2 into C3 by C1 plus C2 plus C3. This is understood? Understood? Now we are able to write effective. C effective what? K into epsilon naught A by D. This only now we want to find out. So C1 what? K1 epsilon naught. What is this separation? D by 2. This separation? D by 2. Tell them. K1 epsilon naught A by 2 by D by 2. Okay. Next, plus C2. So K2, that is also same. Epsilon naught A by 2 by D by 2. Into C3. C3 what? This one. C3 what? K3 into epsilon naught area A only, A, by separation D. Okay, divided by, here what? K1 epsilon naught A by 2 by D by 2 plus K2 epsilon naught A by 2 by D by 2 plus K3 epsilon naught A by D by 2. Okay, so what is the common? What is the common ray? This epsilon naught A by D, this epsilon naught A by D cancel. Okay, next here epsilon naught A by D by 2, epsilon naught A by D by 2. And here epsilon naught A by D by 2, epsilon naught A by D by 2, epsilon naught A by D by 2 cancel. Okay. So here K is equal to what is remaining here? K1 plus K2, K1 plus K2 into there K1 by 2. Okay. And there K3 divided by, here what? K1 plus K2 by 2 plus K. So it will become K is equal K1 plus K2 into K3 divided by K1 plus K2 plus 2K. This is the effective dielectric constant. Okay now? Here this cancellation, okay? Next, here K is equal to, what is remaining? K1 by 2 plus K2 by 2. So K1 plus K2 by 2. Here only K3, K3 divided by, here what is this one? By 2 is there here also. Here only D cancel na, by 2 is there na? By 2 is there na here? Tell re, by 2. So by 2 means here what is remaining? 2 into. Oh, 2K3, good. Here 2K3. So it will become 2K3. Okay. So K1 plus K2 into 2K3 by K1 plus K2 plus 2K. Good. So by 2 goes to numerator 2K3. Here cancel. Okay. So like this we should find out the effective dielectric constant. This combinations okay na? Able to recognize series what, parallel what? Same plate means what? Same plate, common plate. Common plate means what? Parallel. No common plate means what? No common plate means series. Parallel series, how you recognize? Common plate means what? Parallel. Here common plate, parallel. This combination don't have any plates. Plates only this and this. No plate. No plate means what? No common plate means series. Okay. Series parallel, how you recognize? If the common plate is there, then that is said to be what? What a parallel. No common plate means what? Series. Next, another one try to do. K1, K2K, 3K. K, 2K, 3K. This is d by 2 and this is d by 2 and this is A, this is A by 2 and this one A by 2. Okay, this is the separation D. Now, how many capacitors are there? 3. 1, 2, 3. Here try to tell what are in parallel? 1 and 2 parallel and that is in series with third. So, here 1 and 2 parallel and that is in series with 3. That is in series with 3. Okay na? So, effective capacitance, C effective. How we write? Same as earlier. C1 plus C2 into C3 divided by C1 plus C2 plus C3. Okay. Now, C effective is equal to, how you write tell C effective? C1 what? K epsilon naught A by 2 by D by 2 plus 2K epsilon naught A by 2 by D by 2. Next, into what is that one? C3. C3 means 3K epsilon naught what A by D by 2 divided by what? K epsilon naught A by 2 by D by 2 plus 2K epsilon naught A by 2 by D by 2 plus 3K epsilon naught A by D by 2. Epsilon naught A by 2 by D by 2, epsilon naught A by 2 by D by 2, here epsilon naught A by 2 by D by 2. Cancel. Okay. Next, what is this one? You want to find out dielectric constant, or? So, C effective, how you write? K effective epsilon naught A by D, that is equal, here what? K plus 2K into 3K epsilon naught A by D by 2 divided by, all cancel means for this epsilon naught A, so here by 2 into 2, is that much? By 2 into 2. So, divided by what? K plus 2K, 3K, 3K plus 6K, 9K. Now, epsilon naught A by D, epsilon naught A by D. So, K effective is equal to what? 3K into 3K into 2 divided by 9k. Okay. So here 3k 3 ja, 3 3 cancel. So effective, k effective will become what? 2k. K effective will become what? 2. Okay. So like this you are able to find out. Like this you are able to find out. So in pattern directly also formula you are able to remember. What is this pattern direct formula? C1 plus C2. That means K1 plus K2 into 2K3 divided by K1 plus K2 plus 2K3. In this pattern, what is the formula? Okay, K1 plus K2 into 2K3 divided by K1 plus K2 plus 2K3. That's so like this we are able to find out the effective dielectric. We are able to find out the effective dielectric in series and parallel combination. Another one like this also. If all plates are identical and they are having identical separation then CAB is equal how much? All plates are identical in size and identical in separation, then CAB is equal to what? Array, very very important this model, remember. Here like this means consider for one terminal connected to positive charge and another terminal connected to negative charge. Right, see careful. So connected to positive means what? This A connected to upper plate and lower plate. So here positive charge comes, here positive charge comes, here positive charge comes, and here positive charge comes. This is clear? And B connected to negative charge. So here negative charge comes, here negative charge comes, here negative charge comes, and here negative charge comes. This is clear? That means which terminal connected to any one plate means that plate both sides are having the same charge. Okay. So A connected to positive. So this plate connected to A, so up and down positive charge. And this is also connected to this, so up and down positive charge. Similarly, B negative charge. So this one up and down negative, this one up and down negative. By seeing this, how many capacitors are there? Tell. Only two. This is one capacitor and this is one capacitor. The middle region is not the capacitor. Why? Both are negative charged plates. Both are same charge means that is not capacitor. Capacitor means one side positive charge, other side negative charge. So like this. So this one and this one is there. Now if its capacitance is C, try to tell these two are connected in parallel or series. These two, 1 and 2, connected in parallel or series? Connected in what? Connected in series or parallel? Very good, dirty fellows. Same charged plates connected, which combination? Parallel. See, first one positive charged plate and second one positive charged plate connected to A, and first one negative charged plate, second one negative charged plate connected to B. So connected in what? Parallel. Connected in what? Parallel. Parallel means CAB is equal to what? C1 plus C2. So C1 plus C2 means here C plus C. So 2C. What is this one? 2C. Now I will give another one, try to tell. Suppose First what we should do? A connected to positive means what? Positive, 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 positive. B connected to negative. So negative. So this is negative, 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 negative. B negative, 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 negative. Now how many capacitors are there? 3. This is 1, this is 2, this is 3. Now try to tell which are in parallel and which are in series. 1, 2 parallel, 1 and 2 parallel. Why 1 and 2 parallel? 1 positive plate and 2 positive plate connected to here only, and 3 positive plate also connected to there only. And here for what is that one? 3. 1, 2 and 3 all are parallel. Here negative plates, first negative plate, second negative plate, third negative plate, all connected to B. So 1, 2, 3 parallel. So CAB is equal to what? 3C. CAB is equal to what? 3C. Okay now this one? Okay now? Like another one I will give. Another one. Okay, so X, Y. Now find C X Y. Find C X Y. Find C X Y. See X what? Positive. Y what? Negative. So here positive, here positive. Y negative. So here negative, here negative. Now try to tell by seeing that how many capacitors are there? How many capacitors are there? How many capacitors are there? 3. Here capacitor, remember carefully, capacitor means what? That may have opposite charged plates, or that may have one charged plate, one neutral plate. That may have one charged plate, one neutral plate. Okay. Now if you see what is this one and this one capacitor, and this one and this one, 2 capacitors. This one and this one, 3 capacitors. This one and this one, no capacitor. One plate is there. So capacitor means here another point came. What? One charged plate and one opposite charge or neutral. Neutral also. Suppose we wrote one formula for spherical conductor. C is equal to 4 pi epsilon naught R. In that how many spheres are there? Only one. So like this. Now try to tell 1 and 2. How 1 and 2? Parallel. And 3 common point is there? No. So this combination in series with 3. In series with 3. Right. This one understood? 1 and 2 parallel, and 3 not having both common plates. So that is in series with 1 and 2. So how you write CXY? Tell CXY is equal what? C1 plus C2 into C3 divided by C1 plus C2 plus C3. Okay now? So CXY is equal C plus C, 2C into C by 2C plus C. That will become what? 2C by 3. Okay, that will become what? 2C by 3. So, here what you should remember, if they are connected in parallel, C1 and C2, and that combination is connected in series with 3. Why? Because it is not having common plates. Here these two plates are common, but here only one plate is common, one plate connected to somewhere Y. So, we are able to say that what? This is C1 and C2 are connected in series, parallel, and that combination is connected in series with C3, Next, another one. Now, try to do this one. CXY. How many capacitors are there? This is positive and this is negative. So, plus, 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 minus, 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 minus. How many capacitors are there? 3 capacitors. 1, 2, 3. Here, what is that one? This is having neutral plates and positive charge. This is having second capacitor, positive charge and negative charge. Third capacitor, negative charge and neutral plates. Now try to tell what is that combination. What are parallel? First and third parallel. First neutral, neutral, okay. But here positive, negative. First to second, what is common? Positive charge plates. Okay? First, second, series. This combination is parallel with third. Okay, see, first to neutral and positive. So, and what are one? Second positive and negative. So, what are common? 1, 3. 1, 3 series. Second parallel. 1, 3 series means 1, 3. Common what? Neutral. This is neutral. This is neutral. This is, what is that one? Positive and 3 negative. Positive, negative. And second one, this is positive, negative. Positive, negative. Right or wrong? This one. Here identical, so no problem. But if they are having in different size, problem will come. So, what you should remember, like this means parallel series. How? Connected means first you should take. Here 2 series, 2 parallel you are thinking. 1 parallel you are thinking. So, like that. After this, here 1 and 2. What is the common? Positive. So, common means this is positive. Right. 1 and 2. What is that one? Series you are thinking of parallel. Series. So, this is positive, this is positive. One is connected to neutral and second one, another one connected to negative. Now, this one is possible? No. So, wrong. So, immediately we should change. We should take 1 and 3. 1 and 3. 1 and 2 are not possible. So, we are taking 1 and 3. Now, here 1 and 3, common what? Neutral. So, neutral, neutral. Common plates. And here 1 is connected to positive, third is connected to negative. So, this is positive means this should be positive. This is negative means this should be negative. Why? These two are again connected now. Okay. Now, this is the correct combination. Like that you should, what is that one? Trial and error method practice carefully, automatically we are able to get the idea. Okay, in trial and error method, try to practice that one. Okay, if values are identical, no problem, but values are not identical means what? Problem will come. Values are not identical means problem will come. Next one. Energy loss problems, no? If both capacitors are connected in parallel, positive to positive, negative to negative, then what is the energy loss formula? Half C1 C2 by C1 plus C2 into V1 minus V2 whole square. In opposite polarities means V1 plus V2 whole square. Okay. Opposite polarity means energy loss will be more. Same polarity